We are on the mean tab of the data set. We've switched from the frequency now to the mean. We have 3 columns of data, 3 measurements, and 1 descriptor. So we're going to start off with the mean. The mean is another word for average. And that is exactly what Excel uses. So I'm going to double click on average and highlight the data. Gives me an average of 6. The average is just like the mean is just like the average. Take the number, divide by n, or sum it all up, divide by n. The median is the midpoint between the highest and the lowest. So high and the low, divide by 2. So median, parenthesis, write the data, and then the mode is the most common. When you have all 3 line up, that data is normally distributed, or it is symmetrical. So in terms of skewness, there is no skewness whatsoever. It's perfectly symmetrical. And we'll see this when we start getting into the graphs. Now we're going to apply these 3 functions to the rest of the data. So I'm going to go ahead and move it over. You'll notice that the data changes quite a bit and that they no longer line up as they should. So what that means is we've got outliers on one side or the other. Okay? And to really understand what's going on, let's go ahead and do a histogram of the data. So we're going to highlight our X. I'm going to go to Megastat, Frequency Distributions, Quantitative. I'm going to enter in my output range. And I'm going to put my interval width as 1. I'm going to leave the lower boundary blank. It'll automatically pick up the first one, meaning we don't have a lot of data points and the range is just going to be 1. Otherwise, we're going to see some weird distributions. And push OK. Okay, going to copy the data, or the chart. And then make it small enough to where we can have all the others in there. And I'm just doing this for the rest of them as well, so we get a nice visual on what's going on. When looking at data for the first time, one suggestion is to look at the data via a histogram, just to see what's going on and get an idea of what it looks like. Especially if you have no idea what the data looks like whatsoever. Fresh new data set, and just want to take a quick little peek at it. All right. The last graph. Oh. And that looks like the last one it is. So sometimes you get this error message with Megastats. And so sometimes what you need to do is just clear everything out. Try it again. And it should work. Yep. Okay. Let me zoom out here a little bit, and there we go. All right. So the first one is our X set of data. It looks like it's nice and symmetrical. So we have 0 skewness, which means one side looks exactly like the other. Kind of convenient. It is a quick up problem, so yeah, everything looks nice. On the right hand side, this is variable y. You'll notice that the most of the data is over on this side. Then you have 3 kind of points over here, 1, 1, and 1. This would be called the tail or the outliers. Now in determining skewness, you look at where the tail is pointing, not where the mass is. So in this case, the data is skewed to the left or negatively skewed. It's pointing towards the negative sign. So we're going to put that in here. Negative. And the opposite is true of the z values, where it is positively skewed. Okay. And the pictures describe it so well. But if you need to, you can look at the numbers as well. You can notice with the negatively skewed data over here, the average is lower than the median or the mode. It's because these numbers are pulling that mean over this way. The opposite is true over here. The outliers are pulling it over onto the right-hand side, meaning it exaggerates the mean. And so the mode is the most common, which is 5. It's the lowest. In this case, this one's the highest. And we can see that graphically as well. So for analysis sake and bringing it all together, mean, median, and mode are used to measure centrality. Depending on what you're looking at or depending on the question you're asking, each one will tell a slightly different story. The mean will tell you the average overall. The caveat, though, as we've seen, is outliers tend to pull it one direction or another, meaning if you have a really big number or a really small number, they can alter it or change it dramatically. Mode is the most common, which can be important if that's what you want to know, and median is just top, highest, lowest, and in the middle of it. The next video is going to look at dispersion of the data. That's going to be found on our standard deviation tab.